Hey guys and gals, it is Mr. V. Hey, this is going to be your first lesson video that we're going to do. Now this one's a little different because to avoid homework over the weekend, I'm going to have you watch it tonight and hopefully be ready for Tuesday for our first lesson. So this is going to be our first unit lesson where we have our book out and we're kind of doing our first real major 5th grade content. Okay, so what you should have with you or in front of you, you should have your notebook and a pencil. You should be doing everything I'm doing. So I write, you write. Cool thing about a video is you can pause me if you have to go run and do something real quick, go to the bathroom, anything like that, pencil breaks. You can rewind me if I went too fast. You can replay me. So this is what's great about having a lesson video is you can always go back to it if you're not sure what's going on. Okay. Now, when I do this video, I'm doing the highlights. So I'm not going to necessarily do everything I'm going to do in class, but this is just to give you one to help you know what we're going to be doing in class. So it kind of gives you that edge to like, hey, okay, this makes sense. I already know what I'm going to do, which helps us to go faster in class and then helps us to do our homework in class instead of just taking it home. So that's why these videos are important. So secondly, it also allows you to go back. If you get stuck or you're not sure, you have homework to do, you can always pull this video back up to show you how to do it. Okay? So this is actually called Powers of 10 and Exponents. Okay? So this is going to be our first lesson from the math book, but you won't have to get that today. Okay? So this is Powers of 10 and Exponents. Now, you've heard of exponents a little bit already because exponents are in order of operations. So, and how they work in order of operations are pretty much how they work here, except we're going to be only using the number 10 or powers of 10. So like 10, 100, 1,000, and so on. Okay? So that is it's going to make it a little bit easier. So go ahead and make sure you title your notes. You should be on a clean sheet, nothing on the front or the back. Okay? So first off, we're going to talk about what are powers of 10. Well, powers of 10 are anything that dealing with 10. So like 10, 100, 1,000. Okay? Stuff like that. 10,000. You'll notice the powers of 10 are just basically like our place value like we already worked on. So when we did place value last week, we were doing the place values and jumping and going up 10 times greater and stuff like that. You're going to see this is kind of the same thing. Okay, so we're going to talk about, well, what are powers of 10 and how do exponents happen? Okay, or what do they do? Okay, so we're really going to kind of focus in on that. Okay, so these are our powers of 10, and obviously they would go on forever. So, well, what is an exponent? How does that work? How do the powers of 10 work? And we're going to show you how it works. We're going to show you some kind of cool tricks with it and kind of all that. So we're going to kind of recap. We are going to remember that this number is called the base. Now, again, in 5th grade, our base, when we do exponents, are always going to be a 10. We're not going to worry about much else, okay? And that actually makes it easier and gives us some shortcuts, actually, that are going to be really nice to use. This guy is called the exponent, which, again, we've learned in order of operations. What the exponent's job is to tell me how many times I'm going to multiply the base. So if you watch, this is what he is. He is 10 times 10. That's what this 10 to the second power means. And that's how you say that. 10 to the second power. Or remember, if it's a 2, you could say 10 squared. Okay? But that's all that means. It tells you how many times to multiply the 10. Not add, not multiply these two numbers. You never, ever take the base and the exponent and just multiply. That's a very common mistake, though. And then our answer would be 100 when we solved it. So 10 to the second power is another way to write 10 times 10, or it's another way to write 100. Now, we'll do a couple of them, and while we're doing this, I want you to see if you can figure out or what you see with a pattern. Remember, we talked about patterns everywhere in math. What pattern do you see? So now let's do 10 to the third power. What is 10 to the third power? Well, again, the exponent tells us how many times to multiply 10. So here I had the exponent of 2. I had to multiply 10 twice. This time I have to go 10 times 10 times 10. And if you notice, a wrong answer would be 30. Remember, we're not adding these, we're multiplying. So if you think to yourself, well, what's 10 times 10? And if I solve that, that would be 100. And then 100 times 10, that would be 1,000. My answer would be 1,000. Okay? So remember, you're multiplying, not adding. So then 10 times 10 times 10 is 1,000. See any patterns yet? See anything you notice? We'll do one more, and then we'll see if you can identify it. Let's go big here. 10 to the 6th power. What does that mean? So that means 10 times 10 times 10 times 10 times 10 times 10. Big, huge problem, right? And that's why they've come up with this exponent guy, so you don't have a huge, long problem like that. You can write 10 to the 6th power is the same thing as writing this. Well, what would my answer be? Well, if you've paid attention up here, do you see any shortcuts? Do you see any tricks or hints or things that we could maybe figure out? Well, if you look, we have when the base is a 10. Now this only works when the base is a 10. And you look, let's see, I have the 2 up here. Notice how many 10s there are. There are 2. But notice in your answer how many zeros there are. There are also 2. Do you think that's a coincidence? Or do you think maybe that's a pattern? I don't know. Let's check it out. So then we have 10 to the 3rd power. Notice we have a 10, and a 10. And I now have 3 zeros. And my exponent is a 3. Is that a pattern? Or is that a coincidence? So far, so good, right? Well, technically, if I did 10 times 10, 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000, times 10 is 1,000,000. Technically, my answer is 1,000,000. And look at my zeros. 6 zeros, 6 for the exponent. Aha! I think we found a pattern. And the reason this works, and we'll talk about this more in class, the reason this works is that this powers of 10 is exactly how our place value system is based on. So again, think if this was the tens place. Tens, and every place value we learned is 10 times greater. So if I multiply by 10, I'm now 10 times 10 is 100. And the next place value would be 1,000 because I got 10 times greater. So every time I get 10 times greater, it looks like I'm jumping up the place value chart. So 10 to the 6th power is like, and I'm going to do my air quotes, adding a 0 every time I multiply by 10. Now, am I really adding a 0? No. No. I'm not. I'm multiplying by 10. And this only works with whole numbers. If you go ahead and jump into decimal land, which we will soon, you can't just add zeros. Okay? So technically what you're doing, we're getting 10 times larger. We're shifting up the place value chart. Okay? That's technically what I'm doing. I'm taking my 10 and he's getting pushed over and over and over. Okay? So again, if I did 10 to the 4th power, this technically would be a 1 with 4 zeros. Okay? The exponent, and I'll even write that down, will tell you how many zeros are in your power of 10 number. Okay? Only works when the base is a 10. And again, if I'm going too fast, pause me, guys. If I'm going too fast, pause me. Pause me, see what you have to write, and then start back up. But again, let's see the rule here. Let's see the pattern. Remember, this is called the base. This is called the exponent. The exponent tells me how many times to multiply the base. So 10 times 10 times 10 times 10 times 10 times 10 times 10. But I'm multiplying, I'm not adding. So it's not 10, 20, 30, 40, 50, 60. It's 10 times 10 is 100, times 10 is 1,000. So it's like I'm walking up my place value chart. Okay, what I notice is at the end I ended at 1,000,000, and I have 6 zeros. So I have my 1 with 6 zeros. Notice here, the exponent tells me how many final zeros. Okay, so a quick trick or pattern would be when you have a base of 10 and the exponent is a 6, it's going to have 6 zeros in the answer. Okay? It's not going to have 6 zeros plus the 10. It's 6 total zeros. So I'm going to flip my page. So let's go and do 10 to the 5th power. Okay? So you can see it. Technically, that's written 10 times 10 times 10 times 10 times 10. But my answer would be a 1 with how many zeros? Well, look at the exponent. The exponent's a 5, so that tells me 5 zeros. 2, 3, 4, 5. Put your comma in. So this would be 100,000. And then I could do it in the math right here. 10 times 10 is 100. Jump to the next place value, 1,000, 10,000, 100,000. So kind of do that with me. You have 10. You multiply it by 10. So now you jump to 100, jump to 1,000, 10,000, 100,000. Again, this works, and it's just like our place value system, because our place value system is based on a base 10 system. Okay? So that's kind of how this works. Now I got a question. What if I added some extra multiplication to it? What if I decide to go 3 times 10? And let's say let's just start with that. What would be 3 times 10? That's pretty easy, right? 3 times 10 would be 30. Well, what if I did 3 times 10 to the 2nd power? Okay, well, what would this really mean? Technically, this is, and by order of operations, I got to do the exponent. Technically, that's 3 times 100 by what we just learned, because this is 10 times 10. And then I would have 300. Okay, what if I had 3 times 10 to the 5th power? Well, technically, this is 3 times a 1 with 5 zeros. 1, 2, 3, 4, 5. Sometimes you got to slow down and count. And then when you multiply that, you would just see, what I like to say is find the basic fact. 3 times 1 is 3. And then all the zeros would be 1, 2, 3, 4, 5 would be 300,000. So this even works if you're going to multiply by a single digit number. Okay. What if I said 7 times 10 to the 3rd power? Okay, well, I know 7 times 1 is 7, and I know the exponent tells me how many zeros are going to be on the end. So that would be 1, 2, 3 for 7,000. How did that really look? Well, technically it's 7 times 1,000, which gives me 7,000. So that's the problem. It's just written in what they call exponential form. It's written with an exponent instead of making huge numbers. They use exponential form a lot when it comes to like science and astronomy, when you're dealing with space and you're talking about many zeros. If you're saying the distance from like Earth to like the sun or the moon or anything like that. So that's when they'll use that, because it'd be too long to write a number. What if the exponent was 28? That's huge. You're not going to want to write 28 zeros. So that's why they came up with this exponential form. Okay? But you notice it's the same rule. The number of the exponent is the number of zeros we have. We just had to first multiply what I call the basic fact. So find whatever the 7 times 1 is, and anything times 1 is itself. That's why it's always going to be the same number. If you notice, every time it was a 3, it was a 3. Why is that? Because technically you're multiplying, when you do it, if we did this longhand, we're multiplying by the 1 and the 7, and it's going to be the same number. This is kind of a shortcut. Okay, so I am kind of teaching you a shortcut, but we have to make sure we understand it. We always understand shortcuts. We don't ever just do them. Okay, this would work if the number was 23. Say it was 23 times 10 to the 2nd power. Okay, looks kind of scary because now it's not a basic fact, but technically it is, because technically all it is 23 times 100. And how would we do that? Well, because I know there are 2 zeros, those 2 zeros mean 10 times larger, 100 times larger. Because remember, every 0 you see means 10 times. Okay, so technically this guy's 100 times larger. So if I do the basic fact, 23 times 1, I know it's 23. I can put the 2 zeros to make them 2300. In class, I'll actually show you what this would look like if we did it the messy way, because technically what we're doing is we're pushing the 23 up the place value chart. So technically, and this is it, this is what I mean by the messy way. So technically, if I want to make this 100 times larger, this too has to go up to place values. So 10 times, 100 times. So now he's really there. Then the 3 would go up to 100 times more because I'm multiplying by 100. So he's 10 times, 100 times would go there, but then I have 2 empty place values, and I would have to fill them with zeros. So that's kind of the messy way to do it. It's hard to see. This is kind of our shortcut. This is how it's working. But we're going to make sure we truly understand that we're making this number 100 times larger, which means he's moving up the place value chart 100 times. Okay? And we know every 10 times is a different place value. So if 100 times, that would be 2 place values. So we shift everybody 2 place values. Okay? So let's try 1 or 2 more. What if I had, did 6 times 10 to the 5th power? What does that look like? Well, if we drew it out, I would have 6 times a 1 with 5 zeros. Okay, pretty nice, right? If I had to solve that, I'm going to find my basic fact. 6 times 1 is 6. And then I know I got to add, remember, air quotes, because you're not really adding them. You got to add all the zeros to the end, because what's happening is you're going to push the 6 up the place value chart. 10, 100, 1,000, 10,000, 100,000 times. So I need to go 1, 2, 3, 4, 5. So when you do that, no longer is the 6 just a 6. He's now 600,000. You moved him from here by putting all the zeros all the way to here. Okay? So that's what powers of 10 and exponents are. It's really related to what we already talked about in our place value on last week. Hopefully this video helps, and we will have a great start when we get to class. All right, guys, reach out if you need anything.